क्या करते जी आप कॉलेज में? कॉलेज में क्या करते हैं? ऑफिस स्टाफ हो? सेम आपका तरह हमारा नीट आईआईटी डायरेक्टर भी सेम फेस करता था. Dear students, Om Sri Guru Vaswalingaya Namaha. Welcome to K-cet online classes. Already you know, in K-cet the weightage of second year is more and first year is less. So here online classes especially to strengthen you. We are taking second year syllabus, we are giving priority to second year syllabus. Afterwards, if the program is extended, then for first year syllabus also it may be going on. Thank you very much. Today I want to start our chapter electric charges. Electric charges and fields. Electric charges and fields. Already you know the total synopsis, but once again we may go through synopsis and we may recapitulate. And on the same day, evening, exam will be conducted in K-cet model. So try to follow the synopsis and try to write the exam in perfect manner and try to achieve very good score. Good score means in K-cet minimum out of 60, try to get 40 plus in each and every subject, minimum. Thanking you. Now we will enter into electric charges and fields. Here first of all we should know what is meant by electric charge. Electric charge. Electric charge means what? Here if any body is considered, already we know that body is having molecules and each and every molecule is having nucleus with protons, and surrounding to the nucleus the electrons are revolving. Protons are having positive charge and the electrons are having negative charge. So suppose here the total positive charge due to protons is considered plus q and the total negative charge due to electrons is considered minus q, then for this atom its net charge is treated as 0 if and only if the number of protons is equal to number of electrons, then automatically net charge will be 0. Suppose here by doing any one process, if we remove the electrons or we may add the electrons, then the net charge should not be equal to 0. Here the process which is used to create the charge, that process is said to be electrification. That process is said to be electrification. Here generally electrification means what? Electrification may be occurred in and induction. Here the electrification process are three. One is friction, another one conduction, another one induction. Due to any process, if the body lost the electrons, then we may say the body is getting positive net charge. Here, due to any one process, that body gains the electrons from outside, then we are able to say that it is having negative net charge during any one electrification process. Here friction means what? Friction means if any two bodies, one is any two bodies which are initially electrically neutral are rubbed. That means those are in contact with any surface and continuously those are rubbed, then the electrons are moving from one body into another body. Here suppose the first body is having name 1 and second body is 2, then after rubbing, if you separate these two, the Q1 charge is, by gaining the electrons, the Q1 charge is negative charge. Similarly, here the second body is losing the electrons, that's why its charge Q2 will be positive. Q2 will be positive. So, due to friction, the opposite charges are formed, acquired by both bodies. Here, those opposite charges are equal in magnitude. Here, conduction means what? Conduction means what? Suppose one body is considered as charged body and another body is considered as uncharged body. I am considering the first one is having plus Q charge initially and the second one is uncharged body. Here, if these two bodies are connected by a wire, if these two bodies are connected by a wire, then this total charge is shared by both. That means what? Here the first body is getting charge Q1 and the second body is getting charge Q2, such that the total charge should be equal to Q1 plus Q2. So, here the Q1 and Q2 both are having the same nature of the charge. That means if this plus Q is positive means Q1, Q2 both are positive. So, already we know the like charges are repelled. That means those two bodies should be repelled after conduction. Here, due to friction means both are getting the unlike charges. One is negative and one positive. That's why friction causes for attraction, conduction causes for repulsion. Next one, induction. Here, in the case of induction, if you see here, the induction is very important one in electrification process. Here, suppose let us assume that this is the positive charged body. That means this is charged body. If any uncharged body is bringing nearer to the charged body, that means this is charged body and this is uncharged body. So, if the uncharged body is bringing nearer to the charged body, then at the nearer surface the unlike charge is said to be induced. And at farther side the similar charge is said to be induced. Due to induction, the uncharged body is gaining two types of charges which are equal in magnitude. Out of those two, the surface which is nearer to the charged body is getting opposite charge and the surface which is far away from the first body is getting the charge like the charged body. And these two are equal in magnitude. Suppose if K is considered the dielectric constant of this uncharged body and Q dash is considered the induced charge, then here the induced charge, we may write the induced charge Q dash is equal minus Q into 1 minus 1 by K. Here the Q dash is equal Q minus Q into 1 minus 1 by K. This Q dash is representing the charge which is nearer to the charged body. That means it is having opposite sign and it is inversely proportional to dielectric constant. If you choose the metal, then K value for metal is infinite. K value for metal is infinite means what? 1 by infinite becomes 0. So Q dash is equal minus Q. Suppose if K is having any other value, then we are able to see about the Q dash value. This is about the, what is that one? The charges, how the charges are formed. Here generally charges are considered, charges already we know, those are two types, positive charge and negative charge. Here you should know about the electric charges regarding their properties also. Here the first one, always what you should remember, these electric charges always conserved. Electric charges always conserved. Always conserved means what? We cannot create the electric charges or we cannot destroy the electric charges. Only the electric charges are able to transfer from one body into another body. The another one, what you should remember, the electric charges are invariant. The electric charges are said to be invariant. Invariant means what? Already we know. Variant means when they are moving. So electric charges are invariant means what? Whether the body is either at rest or in motion, the electric charge remains constant. That means here if the body is at rest, the charge is said to be Q static. If the body is in motion, then the charge is said to be Q dynamic. So here what is that one? Q static is equal Q dynamic. That means whether the body is either at rest or in motion, that there is no change in charge. The another one what you should remember, the electric charges are quantized. Electric charges are quantized. That means what? Here any electric charge should be integral multiple of the one quantity, then that is said to be quantized. Here for electric charge, the charge may be written as plus or minus Ne, where E is said to be charge of the electron and N is said to be the number of electrons and Q is said to be total charge. So that is electric charges are quantized. The next one, here the electric charges are, if we are considering the electric charges, always these electric charges reside outer surface. That means here suppose let us assume that this is one body. If you supply electric charges to that body, those electric charges should be able to occupy only on outer surface. They never move into inside. The next one, here regarding electric charges, the other important one is charges accumulated at sharp points. Charges accumulated at sharp points. That means what? Accumulated means what? Accumulated means addition. That means they are going on increasing. That means they are crowded. That is said to be accumulated. Suppose this is one body. It is having the electric charges like this. Suppose if you made this body shape like this, it is having one sharp edge. If you change the body such that it is having certain sharp edge, then the total charges will be coming to here more and the remaining region is having less charge. That is said to be charges are accumulated. So these points we should remember regarding what is that one? Charges. The next another one what we should remember, these electric charges SI unit is said to be Coulomb. Here already we know the charge of the electron is equal minus 1.6 into 10 to the power of minus 19 Coulomb. That is the charge of the electron. Here what you should remember, these charges are, electric charges are quantized, means what? Any charge should be multiple of 1.6 into 10 to the power of minus 19. Suppose if the charge of the body is given as 1.6 into 10 to the power of minus 20 Coulomb, then how much force is acting on the charge? Means what? We can't find. Why? Because this value is less than the E. Less than the E means what? There is no question of possibility of the charge. So what you should remember? The minimum possible charge is minus 1.6 into 10 to the power of minus 19 Coulomb. Less charge will not be possible. Another one, after knowing about the electric charge, here you should remember what is that one? Coulomb's law. You should remember what is that one? Coulomb's law. Here Coulomb's law is well defined about the forces acting in between two stationary point charges. Suppose let us assume that Q1 is one point charge and Q2 is another point charge, and these two are located about a certain distance r along one line. Now here already we know that in between any two charges which are separated by a certain distance, then automatically those charges may be either attracted or repelled depending upon the nature of the charge. That means what? Here the charge Q1 is experienced by a certain force, that means by the Q2 in this direction, that is said to be F12 bar. That means F12 bar means the force acting on charge 1 by charge 2. And here the another equal amount of force is acting on second charge by charge 1 in this direction, which is said to be F21 bar. That means F21 bar is the charge, the force acting on charge Q2 by Q. Here these two, F12 bar and F21 bar, these two are having the equal magnitude and opposite in direction. We may write F12 bar is equal minus F21 bar. If you want to write the vector notation of this force, that is 1 by 4 pi epsilon naught epsilon r into Q1 Q2 by r square into r cap. Here the force in vector notation, we may write F bar is equal 1 by 4 pi epsilon naught epsilon r Q1 Q2 by r square into r cap. Here what you should remember, here epsilon naught is said to be permittivity of free space and epsilon r is said to be relative permittivity. In other words, that may be called as dielectric constants. Here the epsilon naught, its value is always constant. Permittivity in free space, its value is given by 8.857 into 10 power minus 12 SI units. Here if epsilon naught gone to here, F comes to down, Q1 Q2 means its unit is Coulomb square, per r square means meter square, F means Newton, so Newton meter square. This is the epsilon naught value. Similarly, the other one 1 by 4 pi epsilon naught, which is generally used as K, that is what is that one? 9 into 10 power 9. If you observe it the earlier, this epsilon naught comes into denominator, so the unit also reverse, that may be written as Newton meter square per Coulomb square, that is 1 by 4 pi epsilon naught value. Here the epsilon r is said to be dielectric constant, that may be written as the ratio of permittivity of medium to free space. Epsilon r is equal epsilon by epsilon naught. This is always constant for a given particular medium. Here on Coulomb's law in entrance point of view, we should observe carefully about their corresponding relations. Here the magnitude of force F is equal to, how you write, 1 by 4 pi epsilon naught epsilon r Q1 Q2 by R square. Here what you should remember, same force means F is equal to constant. Same medium means epsilon R is equal to constant. Similarly, same charges means what is that one? Q1 Q2 constant. Similarly, same distance means R constant. Same distance means what is that one? R constant. These points we should remember. That means what? If the same force is acting in between the same charges, then what is the relation between the dielectric constant and distance? Means what? Simply Q1 Q2 constant, 4 pi epsilon constant, F constant. So epsilon R into R square is equal to constant. Suppose two charges, same charges are in same distance. What is the relation between force and their corresponding dielectric constant? Means F into epsilon R is equal to constant. Like that, when we are doing the problems, you should observe carefully. The another one, suppose if more forces are acting, then always the net force should be equal to the vector addition of forces. That means F bar is equal to what? F1 bar plus F2 bar. If you want to write its magnitude, if theta is angle between F1 and F2, then the net force magnitude is given by root over F1 square plus F2 square plus 2F1 F2 cos theta. Here, if theta is the angle between the two forces F1 and F2, then the net force magnitude is given by root over F1 square plus F2 square plus 2F1 F2 cos theta. It is its resultant magnitude. Suppose if you want to know about the direction of the resultant force, then alpha is equal tan inverse F2 sin theta divided by F1 plus F2 cos theta. That means here this direction with respect to the force F1. If you want to write the direction with respect to F2 force means what? Theta minus alpha with respect to F2. With respect to F2, the direction is theta minus alpha. These we should remember carefully when you are able to apply the Coulomb's law. Here the Coulomb's law limitations also very important. What are the Coulomb's law limitations? The first one, the charges should be point charges and those should be stationary charges. That means if the charge when comes into motion, then Coulomb's law is not applicable. And the another limitation is what? The distance should be greater than 10 to the power of minus 15 meter. If the distance in between charges is less than 10 to the power of minus 15 meter, then the nuclear forces will be dominant. So if the distance is greater than 10 to the power of minus 15 meter, then only the electrostatic force is dominating. This one we should remember. After this you should remember another one, that is said to be line of force or lines of force. Lines of force means what? If any unit positive charge is left in the what is that one? Vicinity of a source charge, then the path traced by the unit positive charge is said to be line of force. These lines of force always away from positive charge and towards the negative charge. away from the positive charge towards the negative charge. If the lines of force are crowded, then the charge will be more. If the lines of force are liberated, then the charge will be less. Suppose this is one charge and this is one charge. The lines of force are given like this. The lines of force are given like this. The directions are given like this. The directions are given. Now, here if this is Q1 and this is Q2, what is the nature of Q1 and Q2? Means what? From Q1 the lines of force are, what is that one? Entering into Q1 here leaving. That means what? Q1 not defined. Similarly, for Q2 also lines of force are entering and leaving. So, Q2 also not defined. That means those are not the electric charges. Suppose I will change this diagram like this. Suppose if this is one charge Q1 and this is another charge Q2, now the lines of forces are like this. That means here these are like this and here like this and here like this. Now Q1, Q2, these charges, Q1, lines of forces are entering into the Q1, that means towards Q1. So, Q1 should be negative charge. Similarly, here lines of forces are moving away, here also moving away. So, Q2 should be positive charge. Like this we should remember. The other one, where the charge is more magnitude, means by depending upon the lines of forces. Here lines of force are more, here less means what? Its charge is more, its charge is less. Like that we should remember. The another one, after knowing about the lines of force, next we should remember another concept here which is said to be charge density. Which is said to be what? Charge density. Charge density means what? How the charge is distributed over the body, that is said to be charge density. How the charge is distributed over the body, that is said to be charge density. By depending upon nature of the bodies, here charge densities are three types. One is said to be linear density. And the another one is said to be surface density, and the another one is said to be volume density. Volume density. Like this, here three types of charge densities are there. One is said to be linear density, another one surface density, another one volume density. Linear density denoted by lambda, surface density is denoted by sigma, and volume density denoted by rho. Here generally linear means along length. So lambda is equal dq divided by dr. You may write the charge per unit length. So dq by dr. Which body's linear density is there? Suppose if you take one charged wire. In other words, if you take charged ring, here in the case of wire or ring, the charge is able to stay on only length. So that's why that is said to be linear density. Surface density means the charge per unit area. You may write dq by ds. Here area should require, means what is the example? Charged plate. Charged plate. In other words, hollow charged sphere. Hollow charged sphere. Here if you observe in these two, either charged plate or hollow charged sphere, only charge is able to reside on area. So surface density will be there. Volume density means charge per unit volume, dq by dv. That means in the total volume the charge may be at anywhere. Example is, what is that one? Dielectric. dielectric charged sphere. Dielectric means it is not allowing the charges to move away from it. So, charge is able to appear at anywhere. That's why we may say that dielectric charge sphere, it is having volume density. Unit, if you consider for linear density, unit is its SI unit is dq means Coulomb per meter. Here Coulomb per meter square. Here Coulomb per meter cube. Here area means meter square and volume means meter cube. So Coulomb per meter square, Coulomb per meter cube are units of charge density. So now we are able to know about the charge density by seeing just the object. Just the object we are able to send. So wherever the charge is replaced by density means what? For the charge wire, Q may be replaced by lambda into length. Similarly, for what is that one? Charge plate, Q may be replaced by sigma into area. Similarly, charge sphere means rho into volume for dielectric charge sphere. Like that we should remember. After this, we should know about another one that is said to be electric field. Electric field, which is denoted by E bar. What is meant by electric field? Electric field means what? The electric force acting per unit charge. The electric force acting per unit charge is electric field at that particular point. Here, in terms of charge, if Q is the source charge, then electric field is 1 by 4 pi epsilon naught epsilon r into Q divided by r square. This is the expression for the electric field, where already we know epsilon naught is permittivity of free space, epsilon r is dielectric constant, r is the distance between the chosen point and the source charge Q. So that is the electric field. In vector form means you should multiply with r bar. That is the electric field. This electric field is completely like electric force. So which laws are accepted by electric force? Those laws should be accepted by electric field. In the case of electric field, you should remember their corresponding values. Suppose let us assume that if you consider spherical shell, here already we know shell means what? Empty sphere, inside material not there, and I am considering this is a charged spherical shell, means here the charge is there and its radius is smaller. Suppose if you choose the point P inside the cell about the distance x, then the electric field at point P becomes 0. That means inside the shell there is no electric field. Suppose if you choose P dash is a point on the sphere, then E P dash is equal 1 by 4 pi epsilon naught epsilon r into Q by r square. Suppose if you choose P double dash is a point about the distance x dash away from the sphere, then E P double dash is equal 1 by 4 pi epsilon naught epsilon r Q by x dash square. That means this one we should remember carefully. So if you plot a graph in between the electric field and distance for the spherical shell, we may get like this. Suppose on the x-axis if you consider distance, and on the y-axis if you consider what is that one? Electric field. And this is the origin, and capital R is considered radius of the sphere. Capital R is radius of the sphere. So already we know inside the electric field is 0. So up to here the electric field is 0. At R the electric field will become maximum. So at R the electric field will become maximum. After that, if you move away from the surface, the electric field decreases exponentially. So electric field decreases exponentially. Like that, we may plot the graph for what? For spherical shell. Suppose if you consider what is this one? This dielectric sphere, dielectric charged sphere. Dielectric charged sphere. In the case of dielectric charged sphere, what is the difference? Inside material is there. So inside also charge is there. And here charge resides on outer surface. So here also charge is there. Suppose Q is the charge and R is the radius. Suppose inside about the distance small r, one point P is there, then EP is equal 1 by 4 pi epsilon naught. Here actually what? Q by R square. So instead of that, here Q by R cube into small r. Like that, we may write its corresponding distance. Suppose if small r is equal to capital R, then one cancel, again it will become 1 by 4 pi epsilon r cube by R square. Suppose if you consider P dash is on the sphere, then EP dash is equal general formula 1 by 4 pi epsilon naught q by R square. Suppose P double dash is outside point about the distance x, then EP double dash is equal 1 by 4 pi epsilon naught q by x square. Q by x square. If you plot a graph in between electric field and distance, if you plot a graph in between electric field and distance for this dielectric charged sphere, then if this is the R, inside this is directly proportional to R. So we may obtain the straight line up to R. After that, at R it will become maximum. At R it will become maximum. After that, exponentially decreases. This is the difference in between what is that one? This shell and dielectric charged sphere. This point we should remember carefully. This is about the electric field due to shells and their corresponding what is that one? Spheres, dielectric spheres. After this, you should remember another important one, that is said to be electric dipole. Electric dipole. Dipole, di means what? Two. That means if two equal and opposite charges are separated by a certain distance, then that is said to be dipole. Here, suppose O is considered center and P is considered a point about the distance small r from point O, that means center of the dipole. Then at that point P, the electric field is given by P divided by what is that one? 4 pi epsilon naught r cube into root over 1 plus 3 cos square theta. Here, what is that one? The electric field at a point P, which is making an angle theta with respect to x of dipole. Then the electric field is given by E is equal P by 4 pi epsilon naught r cube root over 1 plus 3 cos square theta. Suppose if you consider axial line. Axial means what? Point P should be along this line then theta will be 0. So 3 cos square theta means cos square 0, 1. So root 4 means 2. So 2p divided by 4 pi epsilon naught r cube. Suppose if you consider point P on equatorial line. Equatorial line means angle should be what? 90 degree. So 90 degree means cos 90 0. So simply it will become P by 4 pi epsilon naught r cube. These are what is that one? The different expressions for electric dipole electric fields. Electric dipole electric fields. The next one. Here the electric fields may be expressed in terms of charge densities. Here that is successfully explained afterwards. The another one what you should remember, in the case of dipole, torque also you should remember. Torque. Torque means what? If any two equal forces and equal and opposite forces are acting about a certain point and it gives the turning effect, then that is said to be torque. Suppose that I assume that this is the electric field. This is the electric field E bar. Here I kept one dipole such that this is a negative charge and this is a positive charge. Then this positive charge experienced by the force F bar is equal to Q into E bar in the direction of electric field, and negative charge experience F bar is equal minus Q E bar in opposite direction. Here if these two are separated by a distance 2a, then the torque due to these two opposite forces is given by tau bar is equal P bar cross E bar. Tau bar is equal P bar cross E bar. Here P bar is the dipole moment and E bar is electric field. It may be written as its magnitude tau is equal to what? P sin theta. Here theta is the angle subtended in between dipole moment and electric field. That means what? If this is a dipole and this is the electric field, this angle is said to be theta. If the dipole is along the direction of the electric field, theta is 0, torque is 0. If the dipole is perpendicular to the electric field, theta is 90, tau will be maximum Pe. This is about torque. Here you should remember another important one also, that is regarding what is that one? Potential energy. That is regarding potential energy. Here the potential energy is denoted by U. Here the potential energy U is equal minus P bar dot E bar. That means the dipole moment and electric field, their scalar product negative value is said to be potential energy. In other words, that may be written as U is equal minus P cos theta. That is potential energy. Suppose if you know potential energy, how you find out force means what? F is equal minus du by dr. That means the negative potential energy gradient is said to be force. So F is equal minus du by dr. These points you should remember regarding the potential energy of the electric dipole. After knowing about the dipole, then you should know another small topic. What is that one? Gauss Law of Electrostatics. Here in Gauss Law of Electrostatics, you should know about the electric flux. You should know about the electric flux. Here the electric flux phi is equal, we may write E bar dot A bar. In other words, EA cos theta. Here according to Gauss law, the flux is 1 by epsilon naught times of the charge enclosed in the given area is flux. So, to apply the Gauss law, first of all, you should create the Gaussian surface. That means, suppose here one sphere is there, then you should create the Gaussian surface like this. Similarly, suppose if any one wire is there, you may create the Gaussian surface like cylinder. Suppose here any one area of the plate is there like this, then you may create the Gaussian surface simply by extending that one. Like this, we may create the Gaussian surface. Here, by considering the number of charges within the Gaussian surface, we are able to apply the Gauss law. Here, suppose if you consider this is one cylinder, if the lines of forces are propagating like this, flux is propagating like this. Suppose this is the A1, this is the A2 and this is the A3 area. At A1, the flux is treated as, that is entering, negative. Here at A2, those are leaving lines of forces, so its flux is positive. At A3, how much entering, that much leaving, so there is no question of flux. So, this is about the Gauss law. Try to apply the Gauss law by using our charge densities. Try to prepare well and write the exam in correct manner. Okay, thank you. Five minutes?
5 minutes is
मैं ऑलरेडी एक्चुअली उनका एप्लीकेशन है फिर ना ओके छोड़ दे